Good evening, classmates and Engineer Tulad. Tonight, our group will virtually report on our assigned topic, which is precipitation. So, what is this precipitation? Precipitation is the process by which all forms of water reach back to Earth from the atmosphere. Precipitation is any type of water that forms the Earth's atmosphere and then drops onto the surface of the Earth. In other words, just a brief information, precipitation came after from the process of condensation wherein the water forms in the atmosphere gets heavy and heavier, and later on it will result to water droplets, and that is precipitation, where that water from the clouds fall to the Earth's surface. Also, precipitation is a major component of the water cycle, and like what I said, it is responsible for the deposition of the water on the planet. To further explain the precipitation process, I will report the first two subtopics, and later on, future engineers Suarez and Faraon will report to the other subtopics. So for the first subtopic is the formation of precipitation. It is where the condensation takes place in the atmosphere and condensation nuclei, which are very small particles in the atmosphere that are composed of dust or salt. These particles are called aerosols, meaning the process of condensation will occur and then there's a presence of condensation nuclei and the other particles will join together and then it will get bigger and bigger. Next, during the initial occurrence of condensation, the droplets are or ice particles are very small and are kept aloft by motion of the air molecules. Once droplets are formed, they also act as condensation nuclei. Again, there's the presence of condensation nuclei. These droplets tend to repel one another, but in the presence of an electric field in the atmosphere, they attract one another and are heavy enough to fall through the atmosphere. So when it gets heavier, it can no longer hold and it will fall to the ground. Some of the droplets evaporate in the atmosphere. Some of the droplets decrease in size by evaporation, and some of the droplets increase in size by impact and aggregation, meaning there are factors that could change the size of water droplets. So this is the presentation of the formation of water droplets in the clouds. First is the saturated air wherein the condensation nuclei is present. Next is for the initial condensation where the particles join together. And then the advanced condensation where there's coalescence around droplets and then they will grow and grow and then they will go through to the precipitation process. There are three conditions that met prior to precipitation forming. First is the cooling of the atmosphere, and second is the condensation of nuclei. Third is the water droplet growth. So let us know more about these three conditions. So for the cooling of the atmosphere, as air rises, the pressure decreases as what Boyle's law states that this will lead to a corresponding cooling in temperature. The cooler temperature leads to less water vapor being retained by the air and conditions becoming favorable for condensation. The actual uplift of air may be caused by heating from the Earth's surface, leading to convective precipitation and air mass being forced to rise over an obstruction such as mountain range. This leads to orographic precipitation or from a lower pressure weather system where the air is constantly being forced upwards. This leads to a cyclonic precipitation. So next is the condensation of the nuclei. Condensation nuclei are minute particles floating in the atmosphere which provide a surface for the water vapor to condense into liquid water upon. So next is the water droplet growth, where water or ice droplets formed around condensation nuclei are normally too small to fall directly to the ground. That is, the forces from the upward draft within a cloud are greater than the gravitational forces pulling the microscopic droplet downwards. So basically, the formation of precipitation requires lifting of an air mass in the atmosphere. It then cools and some of its moisture condenses. There are three main mechanisms of air mass lifting. First is the frontal lifting, second is the orographic lifting, and the third one is the convective lifting. So for the first one is the frontal lifting. Frontal lifting occurs when warm air is lifted over cooler air by frontal passage. It is where the different air masses, such as warm and air masses, and then the less dense will rise up or move. Next is the orographic lifting. It occurs when an air mass rises over a mountain range. So in orographic, the air masses lifted up to a higher altitude because of the mountain barrier wherein there is the process of cooling, condensation, and precipitation. So for the next one is the convective lifting. It occurs when air is drawn upward by convective action such as thunderstorm cell. So in convective, packet of air rises due to heat and then it will create a convective cell. So for the next subtopic is the different types of precipitation, which are rain, snow, drizzle, glaze, sleet, hail. And for the rain, it is a form of precipitation that is in the form of water drops of a size larger than 0.5 millimeter. The maximum raindrop size is about 6 millimeter. Drops of larger size break up into smaller drops as it falls down. So the size of the water drop is larger than 0.5 millimeter. Next is rainfall is the predominant form of precipitation and hence the term precipitation is used synonymously with rainfall. The magnitude of rainfall shows high temporal and spatial variation. This variation is responsible for the occurrence of hydrologic extremes such as floods and droughts. So next is snow. Snow consists of ice crystals in a flaky form. It also an important form of precipitation. So next is drizzle. Drizzle is a fine sprinkles of any tiny water droplets of size less than 0.5 millimeter and intensity greater than 1 millimeter per hour. The tiny drops forming a drizzle appear to float in the air. So drizzle is smaller than rain and then yet it has an intensity greater than 1 millimeter per hour. So next one is glaze. Glaze. The glaze is formed when the air or drizzle comes in contact with the cold ground at around 0 degrees Celsius. So the water drops freezes to form an ice coating. For the next one is sleet. Sleet is frozen raindrops formed when rainfall passes through the air at sub-freezing temperature. And then lastly is hail. Hail is a type of shower precipitation in the form of pellets or lumps of size greater than 8 millimeter. Hail occurs in violent thunderstorm. Also, meaning hail is one of the examples of the solid precipitation.
Next, we will discuss about rainfall characteristics. First, we have size and shape. Raindrops have sizes ranging from 0.5 up to approximately 6 millimeters mean diameter, above which they tend to break up. The science behind the varying sizes of raindrops is rain intensity and speed. Typically, raindrop sizes are all going to vary. Smaller raindrops are towards the top of the clouds, and they then collide and combine to make larger raindrops that end up gaining mass and traveling all the way to the bottom of the cloud. The air between the cloud and the surface pushes back on the raindrop and causes it to look almost like a hamburger. This happens until the pressure of the air becomes so strong that it breaks the raindrop apart, giving us different sizes of raindrops. Next, we have depth, duration, and intensity. Depth is the volume of rain over an area. It is important to the overall hydraulic cycle and replenishment of soil water, and the amount is an accumulation or product of intensity times the duration. Next is duration. Duration is the length of time at which rain occurs. If the rainfall is constant over the entire watershed for a long period of time, the peak discharge will occur at the travel time of the watershed. That is why travel time, time of concentration, and duration are interchangeable. Next is intensity. It is defined as the ratio of the total amount of rain or rainfall depth falling during a given period to the duration of the periods. It is expressed in depth units per unit time. usually as millimeters per hour. Rainfall intensity can vary over time in a single event. The intensity is the slope of the ratio between the amount of rainfall and the duration of the said rainfall. The intensity and the duration are usually inversely related. For example, high-intensity storms are likely to be of short duration, and low-intensity storms can have a long duration. Next is hyetograph. Hyetograph is a plot of rainfall intensity in inches per hour versus time. Hyedographs are often used as input to hydrologic computer models for predicting watershed response to input rainfall. Here we have a mass curve of the total gauge rainfall over a certain area. As you can see, along the y direction is the cumulative depth of rainfall in inches, and along the x direction is the duration of rainfall expressed in hours. The slope formed by this relationship is the intensity of rainfall for that certain period. Here we have the hyetograph. Along the y direction is the rainfall intensity expressed in inches per hour, and along the x direction is the duration in hours. The maximum intensity for the gauge occurred at around 4 a.m. This maximum intensity appears to be the tallest bar on the hyetograph, and as the region of greatest slope on the cumulative precipitation curve. This illustrates that the mass curve is the integral of the hyetograph. As in probability theory, the cumulative distribution function is the integral of the probability density function. Note that the gauge had two distinct periods of intense rainfall. These periods of rainfall intensity have the capacity to produce significant runoff and flooding. Next is point rainfall measurements. For hydrological analysis, it is important to know how much precipitation has fallen and when this occurred. The usual expression of precipitation is as a vertical depth of liquid water. Rainfall is measured in millimeters or inches in depth, rather than by volume, such as liters or cubic meters. The measurement is the depth of water that would accumulate on the surface if all the rain remained where it had fallen. A rain gauge is a weather tool used to collect rain. It measures the volume of water that falls onto a horizontal surface delineated by the rain gauge rim. The volume is converted into a rainfall depth through division by the rain gauge surface area. The design of a rain gauge is not as simple as it may seem at first glance, as there are many errors and inaccuracies that need to be minimized or eliminated. Here we have a picture of a rain gauge sitting on top of a surface to avoid splash. And here is a picture of a standard rain gauge. On the top part is the funnel that catches rainfall, and inside is an inner measuring tube, and this is the outside cylinder. The inner measuring tube is calibrated to the cylinder so that it holds exactly 1 inch of water. Another purpose of the outer cylinder is when the inner measuring tube gets filled up with rainwater. The data collector may transfer the said liquid to another container and pour the contents of the cylinder onto the inner measuring tube until all the rainwater inside the cylinder has been recorded. These records will then be added, and that's how the depth of rainfall is measured.